Welcome to this friendly guide on how to evaluate research studies. I'm going to walk you through the entire process using practical examples along the way. By the end of this lesson, you'll have a clear framework for critically examining any research paper you encounter. Understanding a study's purpose. Let's begin with the most fundamental question. Why was this research conducted? Every study starts with a purpose, a problem to solve, or a question to answer. This is usually stated clearly in the introduction or abstract. When reading research, look for statements like the aim of this study was to, or we investigated whether. These signal the core objective. A well-defined purpose should identify the main variables being studied and the relationships the researchers are exploring. For example, a purpose might be to examine how a new teaching method affects student learning outcomes, or to investigate the relationship between sleep quality and workplace productivity. Assessing publication dates. When evaluating a study, pay attention to when the cited sources were published. This tells you whether the research is building on current knowledge or potentially outdated information. A good study typically shows a mix of older sources and newer ones. If all references are significantly older than the publication date, the research might miss important recent discoveries in the field. Different fields evolve at different rates. In rapidly changing areas like technology or genetics, sources more than a few years old might be outdated. In more established fields like certain branches of psychology or philosophy, older foundational works might remain relevant for decades. Types of research claims. Research studies make different types of claims about their findings, and recognizing these distinctions is crucial for proper interpretation. There are three main types of claims. First, frequency claims simply state how common something is, like 35% of adults report chronic sleep issues, or the average reading score was 72 points. These claims describe a single variable without making connections to other factors. Second, association claims link two variables without asserting causation. Phrases like is associated with, is linked to, or correlates with signal this type. For example, higher levels of exercise are associated with lower blood pressure. These claims recognize that two things tend to occur together, but don't claim one necessarily causes the other. Third, causal claims state that one variable directly causes changes in another, using language like improves, reduces, or leads to. These are the strongest claims and require the most rigorous evidence, typically from controlled experiments with random assignment. An example would be the medication reduced symptoms by 40%. Be cautious of studies that make causal claims without the appropriate research design to support them. Many correlational studies incorrectly imply causation in their conclusions. Research methods overview. Understanding the research method helps you determine how much weight to give the findings. Common methods include: experiments involve manipulating variables and observing the effects under controlled conditions. True experiments randomly assign participants to different conditions, giving the strongest evidence for causal relationships. Surveys collect information directly from participants through questionnaires. They're great for gathering opinions, behaviors, or demographic information from large groups, but typically can't prove causation. Observational studies watch and record behaviors or conditions without intervention. These can be valuable for studying real-world behaviors, but may have confounding variables. Case studies examine a single individual, group, or event in depth. They provide rich, detailed information, but limited generalizability. Meta-analyses statistically combine results from many previous studies to find overall patterns. They can provide powerful summaries of existing research, but depend on the quality of included studies. Longitudinal studies follow the same participants over an extended period, capturing how things change over time. These are valuable for developmental questions, but expensive and time-consuming. Qualitative methods like interviews or focus groups gather in-depth, narrative information. They excel at exploring complex experiences, but typically involve smaller samples. Data collection approaches. The way researchers gather their data affects the validity of their conclusions. Common data collection methods include Surveys and questionnaires can efficiently gather information from many participants, but rely on self-reporting, which may be biased or inaccurate. Direct observations record behaviors as they occur, providing objective data, but potentially influencing what's being observed. Interviews allow researchers to explore topics in depth and clarify responses, though they're time-intensive and may introduce interviewer bias. Standardized tests offer consistent measurement across participants, but may not capture the full complexity of what they measure. Physiological or biological measurements provide objective data about physical responses, but may require specialized equipment or expertise. Archival or existing data analysis uses previously collected information, saving time but limiting what questions can be addressed. When evaluating a study, consider whether the data collection method was appropriate for the research question and whether it might introduce particular biases. Understanding the sample. A study sample refers to who or what was studied. The quality of this sample directly impacts how widely the findings can be applied. When assessing a sample, consider both size and characteristics. Sample size matters because larger samples generally provide more reliable results. Small samples might show effects by chance or miss real effects that exist. However, what counts as large enough varies by field and research design. Sample characteristics tell you who was included. Ask, does the sample represent the population the researchers want to make claims about? For example, a study of college students might not generalize well to older adults or those with less education. Watch for sampling methods. Random sampling produces the most representative results. Convenience sampling is common but less rigorous. Also note demographic details like age range, gender distribution, socioeconomic status, education level, or geographic location. These factors might influence the findings and limit generalizability. Statistical analyses. Statistics help researchers make sense of their data and determine if findings are meaningful or merely due to chance. Here are key analyses you might encounter. Descriptive statistics summarize the data with measures like means, medians, standard deviations, or percentages. These help you understand what the researchers found at a basic level. T-tests compare two groups or conditions to see if their averages differ significantly. For example, comparing test scores between two teaching methods. ANOVA extends this comparison to 3 or more groups. It helps determine if any group differs significantly from the others. Correlation analyses measure relationships between variables, indicating how strongly they're associated and in what direction. The correlation coefficient ranges from -1 to +1, with 0 indicating no relationship. Regression analyses predict one variable based on one or more other variables. They can show how much variance in one measure is explained by others. Chi-square tests examine relationships between categorical variables. Effect sizes tell you the magnitude of findings, how big or meaningful a difference or relationship is, beyond just statistical significance. Pay attention to p-values, which indicate the probability that results occurred by chance. The traditional threshold is p less than 0.5, meaning there's less than a 5% chance the finding is due to random variation. Identifying limitations. Every study has limitations, factors that restrict confidence in the findings or their applicability. Good researchers acknowledge these openly. Common limitations include sample issues. The sample might be too small, too homogeneous, or not representative of the target population. For example, studying only college students limits generalizability to other age groups. Methodological constraints. These might include short study duration, measurement problems, lack of control groups, or no random assignment. Confounding variables. Factors outside the researcher's control might influence the results. For instance, a study on a new teaching method might be affected by differences in teacher enthusiasm rather than the method itself. Self-reporting biases. If participants report their own behaviors or feelings, they might misremember, exaggerate, or respond in socially desirable ways. Correlation versus causation issues. Many studies show relationships between variables but can't prove causation due to their design. Limited context. Research conducted in a specific setting might not translate well to real-world situations. Ethical constraints. Some important questions can't be studied experimentally for ethical reasons. When evaluating limitations, consider whether they fundamentally undermine the conclusions or just suggest modest caution in interpretation. Applying research to practice. Research isn't just for academics, it should inform real-world decisions and practices. When considering applications, ask, how robust are the findings? Stronger evidence warrants more confident application. How relevant is the research to your context? Consider whether the study population, setting, and conditions match your situation. What's the risk-benefit balance? Even modest evidence might justify action if the potential benefits are high and risks or costs are low. Are there practical barriers to implementation? Sometimes research findings are valid, but difficult to implement due to resource constraints or organizational factors. Research can inform practice at different levels. Personal application might involve changing your own habits or approaches based on evidence. For example, adopting study techniques shown to improve retention. Professional implementation could mean integrating research findings into your work practices, policies, or recommendations to clients or patients. Organizational application might involve creating new programs, policies, or systems based on research evidence. Policy development at institutional or governmental levels can be shaped by substantial research findings, especially when they address important social or health issues. Remember that good application of research requires both understanding the evidence and considering practical realities and contextual factors. Final thoughts. Evaluating research is ultimately about critical thinking, not just accepting findings at face value, but examining how they were produced and what they really mean. With practice, this process will become more intuitive, allowing you to quickly separate robust studies from weaker ones. The strongest conclusions come not from single studies, but from patterns across multiple studies using different methods and samples. Look for consistency in findings, especially when researchers approach questions in different ways. By systematically examining purpose, methods, samples, analyses, limitations, and applications, you'll develop the skills to be an informed consumer of research in any field. This will help you make better decisions, both personally and professionally, based on the best available evidence.